Hi, this is Steve with Nee Family Lights. If you're new, welcome. If you're not, welcome back. In this video, I'm going to test the specs of 10W RGB floods. The box looks like this, and the floods look like this. They come with typically 18-inch connectors. These have the Ray-Wu ends, and you can get X connects as well. So we'll test the specs of these. We'll see how many of them we can run off of one output, and then we'll see a number of different options for running them with various lengths of extensions to see how well they do and how many we can drive. In my show, I use 11 of these floods. They're mounted upside down under the eaves. There's 4 over the garage, 3 over the middle section of the house, and 4 more on the right side. They all reflect on the white surfaces of my house, and I run them anywhere between 80 to 100%. Typically, I've been running them at 80%, but for the purposes of this video, we'll test them at 100% to see how well they do. If you find this video useful, hit that like and subscribe buttons so you don't miss any of my future content. Let's get to it. Okay, so here's our test setup. We've got the 10W flood here with the standard pigtails, and I have a amp voltmeter tester that I am adapting to the Ray-Wu connector here so we can see the voltage at the end. And I've also got one here in the beginning with a volt and ammeter as well, so we can see how much power is being drawn by the flood. I'm using output 1 on the Falcon. You can see the Falcon here, and the power supply is set at 12 volts there. It's also showing 12 volts here. All right, let's step through it. We're going to go from 100 down to 10% in 10% increments to see how much power it uses. Okay, we're all set up here. So you can see the 10W flood here in the middle. It's running off of the 12 volts right off the Falcon on the first output. And you can see that both the meters on the beginning and the end are showing 12 volts. So if you take 10 watts divided by 12, we are expecting to see 0.83 amps on that first meter at 100% on full white. So I'll go ahead and turn it on white. And we are looking at 0.2 amps. So that is about a quarter of what we expected, 0.83. So this is a good thing. One, you can drive a lot more floods than you think off of one. And the other thing is you're less likely to have any data corruption when you're driving a lot since you're not drawing as much power. So why don't we go ahead and step through every 10% and see how that looks. Setting it to 90%. All right, 0.18 amps. Setting it to 80%. 0.16 amps. Setting it to 70%. 0.13 amps. Setting it to 60%. 0.11 amps. Setting it to 50%. 0.08 amps. Setting it to 40%. 0.06 amps. Setting it to 30%. 0.04 amps. Setting it to 20%. 0.02 amps. And setting it to 10%. It's so low, it's rounding down. So something under 0.01 amps. Okay, as we look at all this data in a table, the actual amount of power used is no more than about 25% of the expected output power. And as we dropped from 100% down to 10%, it was pretty linear through about 60%. And once we got to 50 and below, it dropped off a little bit faster. It was kind of off by 10%, as you can see here. Okay, next let's take a look at chaining a number of these 10W floods together. Okay, so let's take a look at our setup for chaining the lights. As I mentioned, I mount my floods under my roof eaves. So I've got these floods connected here, and they're just attached to these blocks of wood. That's 2, 3, 4, 5, 6, 7, 8, 9. And we're gonna start with 9. I have 10 and 11 here. And again, we're off the first output on the Falcon, running at 12 volts. and we'll have our meter here at the front. And with 9 of them, you can see they're using 0.04 amps, which is a very small amount of power. And we can see the voltage, there's a little bit of drop across all those lines, 11.9. Now this is not very realistic because these are just chained right off of each other. In your show, you're probably gonna have extensions in between, and we'll get to that here in a minute. But when I first was looking at these floods, I thought, okay, 10 watts, 0.83 amps, at most I can run 6 floods at one time, and that'll get you very close to that 5 amp limit. So for me, I plan to use 4, but knowing that these use a lot less power, let's see how it does. Gonna turn them on all white here. Okay, so they're all on all white. So it's dropped a little bit from the lead-in pigtail to 11.6 volts. We're drawing 1.99 amps, and all 9 floods look fine. And you can see the voltage at the end here is 10.1. All right, let's go ahead and plug in a 10th light and see how that looks. Okay, now I connected the 10th light, so you can see the meter at the end there. Put them all on white, and we are now showing 11.6 volts at 2.29 amps and 9.6 volts at the end, and everything still looks pretty good. Okay, let's go ahead and add the 11th light. Okay, the 11th flood is added in, and the meter is now at the end of 11 10-watt floods. We'll kick them all on. And we are at 11.5 volts, 2.66 amps, still a far cry from drawing 5 amps. And we're down to 9 volts here at the end. And they all look really good. Let's go ahead and grab one more. I do have one more here. Let's try that. Okay, I've added a 12th one, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 with the meter at the end. And we'll turn them all on 100%. And now we are at 11.4, 2.9 amps. We are at 8.5 volts here at the end. It's difficult for you guys to see, but that last flood or two is kind of yellowing now. So I'd venture to say that the voltage regulator needs at least 9 volts or so, somewhere in that range, to maintain color of these 10-watt floods. Okay, again, this was not very realistic, but it can be done if you wanted to run a bunch of these floods together. Let's go ahead and put some extensions in and do some realistic testing here. Okay, I've got it set up for the extension test. Before I go into that, what I want to show you is my pigtails are typically not the Raywu type, so I have these little adapters that go to the pigtails that have the Raywu, so that way I can connect up the floods. For the floods over my garage, I actually use this extension just as it is. This is about 3 feet, and I'm able to connect one of the floods to the next ones just by using these 2 pigtails connecting to the pigtails from the floods. So this is about 18 inches here, plus 3 feet, plus another 18 inches, and that's far enough that I can connect my floods over the garage. So what I'm using for this test are standard 18 gauge 3-core pre-made 10-foot extension cables. And what I'm doing is I'm connecting and using these little pigtails to adapt the ends, so that way I have the correct Raywu connectors to connect to the floods. So what I'm doing is for each of the leads, I have a 10-foot vendor plus 2 of these pigtails. So it's a little longer than 10 feet. It's more like 12 to 13 feet with this extension. So I have 6 floods here, and we'll start with 5. 1, 2, 3, 4, 5. And there's the 6th, but I have the meter after the 5th one. And as you can see here, I have the 10-foot extension between each of the floods. So coming off of the first output here, it's going into the volt ammeter, so we can see how much power is being drawn. We have the first 10-foot extension going to the first flood, another 10-foot extension to the second flood, 10-foot extension to the third flood, 10-foot extension to the fourth flood, 10-foot extension to the fifth flood, and we have a voltmeter here. So let's go ahead and turn this on. I'm going to leave it at 100% output, as that will be more representative to try to splash as much color on your home for your show. So here they are in all white. They look good. So we have 11.7 volts, 1.25 amps, 4 to 5, somewhere in there. And 1, 2, 3, 4, 5. They look great, and we're at 8.5 volts here at the end. This last one is a little, I can barely tell that it's a little yellow. All right, let's go ahead and add the 6th one and see how that looks. Okay, I've added the 6th one in. So let's take a look at how that looks on full white. All right, it's hard for you guys to see, but the last two are definitely yellow now. We're at 7.9 volts here. See how much power is being drawn. 11.7 volts, 1.34 amps. So running 5 of these is probably your limit, and it's not for drawing too much power. It's more of a voltage loss across all of these cables. Now, if you use much better quality extension cables that are custom made, then you'll have better success with running these without having that voltage loss. Next, let's test how far we can come off the controller. So I have a 20-foot lead. I added another 10 feet here at the beginning, and we are going to drive 1, 2, 3, 4, 5 floods and see how well that works. All right, so they're all on. At the end, we're at 8.3. There is some yellow discoloration on this last flood, but the first 4 are looking pretty good. And we're at 11.8 volts, 1.21 amps. Let's go ahead and drop out the 5th flood. Okay, now we're down to 4 floods with a 20-foot lead and 10 feet in between each flood. And we'll turn on all white. We're at 9.1 volts here at the end, and all 4 floods look great. So we're at 11.8, drawing 1.04 amps, 20-foot lead to the first flood. Let's try a 30-foot lead and see if we can drive 4 of these floods. All right, so I'm gonna add another 10 feet, so we'll have 30 feet coming from the controller going to the first flood. So here's 10 more feet. And we're still driving the same 4 floods. You can see that, 12 volts there. I'll go ahead and turn on all the lights on white. There we are getting some flickering, so we have some bad data. Now mind you, this is the standard output of the Falcon controller that has the 100 ohm resistor network. I'm gonna switch it over to port number 3, which is where I switched out that resistor network to a 33 ohm and see if that fixes the data corruption problem. And I'll bring the last voltmeter in. It's showing 8.8 volts. So we have enough power, it's just we're just getting some flickering here. So if I switch over to output number 3, it's also at 100%. And there we go. 11.8 volts, 1.02 amps, and we have no flickering using the 33 ohm output resistor network. And I'll show that to you real quick. We have 8.8 volts here at the end, and output number 3 is right here. It's right here. And it's using this yellow 33 ohm resistor network. If you're curious about that 33 ohms, check out my previous video on the power of 33 ohms. So if you've seen my videos before, you know I like to push the boundaries. So we're gonna try the custom extension cable. And if you haven't seen it yet, you can check out my how to make custom pixel extension wires. I'm gonna take the worst performing 40-foot extension cable that we made, which is made out of this solid core Cat 5e cable, and connect that. I've got it back on output number 1 using the 100 ohm resistor network from the Falcon, and we're going to come off the meter, go 40 feet through our worst 40-foot extension performing cable, which is still better than the standard 10-foot extensions. I'll find the end here, and we'll connect it up. And I think we have everything in view here. So 11.8 volts, 1.03 amps. All 4 floods look great. And there's no need for an F amp if you're running with a custom extension cable. 8.9 volts at the end, so the color looks great. Let's push this a little further and see if we can go 80 feet. So coming off the controller, I'm going to take the second worst performing custom extension cable of 40 feet, which is the stranded Cat 5e cable. And I'm going to add that to the line here. So coming off the controller into the tester, go into the stranded Cat 5e cable, and then into the solid Cat 5e cable. And looks like we have some data corruption. Now this is with the 100 ohm resistor network of the Falcon output. Let's try the F amp and see if that cleans it up. All right, so coming off of output number 1, which is the 100 ohm resistor network, into an F amp, and then into our meter in the 80 feet. And that cleans it up. Looks great. 11.7 volts and 0.99 amps, and 8.4 volts at the end, which is a little low, but it'll pass if you're trying to go 80 feet. Now let's try it with the 33 ohm resistor network output on output number 3 here. So I'm gonna remove the F amp, and we'll set the F amp aside and connect the 80 feet coming off of my output number 3, which is using the 33 ohm resistor network. And that works just as fine. And we're about the same here at the beginning, 11.8 volts, 1.0 amps. Now that we've completed a bunch of tests with the 10W RGB floods, let's take a look at all that data in summary. These 12 volt WS2811 based 10W floods are expected to draw 0.83 amps per flood at 100% output. In reality, we saw 0.2 amps, which is about 25%, or about 2.5 watts per flood when it's all by itself. The output power is relatively linear when dropping the output brightness from the controller, and although the floods are not as powerful as expected, it does come with the benefit of being able to chain more floods as a result of having less voltage drop and less chance for data integrity issues. When we chained many directly off the controller, we were able to chain 11 back-to-back right off the controller before color degradation. The 11 floods used 30.6 watts, or about 2.8 watts per flood, pulling 2.66 amps, which is well below the 5 amp fuse limit, and no F amp was needed. When we added a 12th flood, it caused color degradation, and the voltage at the end was below 9 volts. So somewhere around 9 volts is required for flood color quality. Next, we chained a standard 10-foot pixel extension cable lead to the first and between each flood. We successfully chained 5 floods with no F amp needed, and the limiting factor was the voltage drop and color degradation at the end when we added a 6th flood, adding a second standard 10-foot pixel lead for a total of 20 feet to the first flood, and keeping 10 feet between floods. Again, the limiting factor was the voltage drop across at the end. I had to drop one of the floods and can chain 4 floods with a 20-foot lead with no F amp. When we got to 30 feet or 3 10-foot pixel extensions using 4 floods, we had data corruption. We demonstrated it worked using a 33 ohm output resistor network off the Falcon, but the results would be the same if you used an F amp right off of the Falcon controller output. Next, we used a custom 40-foot solid core copper Cat 5e extension cable. It reduced the voltage drop across the run to the first flood. We were still able to drive 4 floods with no F amp using the standard 10-foot extensions between floods. And then we pushed the limits by adding yet another 40-foot custom extension cable, totaling 80 feet from the controller to the first flood. The 80 feet comprised of a custom 40-foot stranded copper Cat 5e pixel extension, plus a custom 40-foot solid copper Cat 5e cable. In this test, we also kept the standard 10-foot cables between floods. Again, we chained 4 floods successfully, requiring an F amp if you're using the standard Falcon output, and no F amp was needed if you use the modified 33 ohm output resistor network on the Falcon controller. If you made it this far, thanks again for watching, and we'll see you in the next video.